Hello everybody! In this lesson, I will discuss 4 real-life examples on the Theorem of Pythagoras. Example 1. A ladder is leaning against a wall. The foot of the ladder is 5 meters from the base of the wall. The top of the ladder is 6 meters from the base of the wall. Calculate the length of the ladder. And there's your little sketch. Now the first thing that you will realize is that there's no labels. So let's label it quickly. Let's call that one A, B, and C. Then the next thing that I want to teach you is that a building or a wall will always form a right angle with the ground. So what can you see? Suddenly there's a right angle triangle. So we can work out the length of the ladder using the theorem of Pythagoras. Remember, the theorem of Pythagoras always starts with hypotenuse squared is equal to one side squared plus the other side squared. Therefore, we can write it as AC squared is equal to AB squared plus BC squared, the theorem of Pythagoras. Then we can substitute. AB is 6 squared plus BC is 5 squared. 6 squared is 6 times 6 is 36 plus 5 squared is 5 times 5, 25. 36 plus 25 equals 61. And then we only want AC, not AC squared. We take the square root both sides. And the square root of 61 is 7,81 meters. Therefore, the length of the ladder, 7,81 meters. Example 2. A boat B is 80 meters from the foot F of a lighthouse L. The distance from the top of the lighthouse to the boat is 110 meters. Calculate the height of the lighthouse. Now, can you see that it was indicated that there's a right angle between the lighthouse and the ground? Therefore, we have a right angle triangle. We can use the theorem of Pythagoras. Remember, the theorem of Pythagoras starts with hypotenuse squared is equal to one side squared plus the other side squared. So for this situation, it's LB squared, that's the hypotenuse, equals LF squared plus FB squared. And the reason, Pythagoras. Now we can substitute. LB's length is 110 squared equals LF squared plus and FB is 80 squared. 110 squared is 110 times 110, which is 12,100, equals LF squared plus, and 80 squared means 80 times 80, which is 6,400. Then let's let it walk across. 12,100 minus 6,400 is 5,700, equals LF squared. And then we want only LF, so we take the square root both sides, and LF's length, the height of the tower of the lighthouse, is 75,5 meters. Before we continue, have you subscribed yet? Or you can like this video, and better yet, please tell your friends about my channel. Let's continue. Example 3. A street and B street meets perpendicularly. Calculate the diagonal distance from James's house to Sarah's house. Now, when you look at the sketch there, where it says they meet perpendicularly, that means it's this angle over there. That's a right angle. So when we want to find the diagonal distance, it implies we want the hypotenuse of a right angled triangle. So by now, it's very clear you understand. It's going to be the theorem of Pythagoras, which says Remember, hypotenuse squared equals one side squared plus the other side squared. In this case, it's JS squared equals JR squared plus SR squared. And we add Pythagoras. Now we can substitute. JS, that's what we're looking for. JR, it was given on the sketch, was 2 squared plus, and SR is 1,5 squared. Then 2 squared, 2 times 2 is 4, plus, and 1,5 squared means 1,5 times 1,5, which is 2,25, plus 4 is 6,25. But then remember, we don't want JS squared, we want JS. So therefore we will take the square root both sides, and the answer, the length JS is equal to 2,5 miles. Example 4. A man S is standing 12 meters from the foot R of a building. He places a 13-meter long ladder against the building Q and a 20 meters long ladder at the top P. Calculate the vertical distance PQ between the two ladders. So let's go to the sketch quickly. Can you see that there's two triangles? There's the right angle triangle SQR. Now, how did I know it was right angled? Remember, the street and the floor makes a right angle with the building. And then there's also this other right angle triangle PSR. So it's very clear that we will use the theorem of Pythagoras here. Now, what are we looking for? We are looking for this little distance over there. So we will work out the distance of SR first, and then we will work out this whole distance PR, and then we will subtract the two. So let's start. In triangle SRQ, that's the little triangle. It's a right angle triangle, so we will use the theorem of Pythagoras. Hypotenuse squared equals one side squared plus the other one. In other words, SQ squared equals SR squared plus QR squared, Pythagoras. Now we can substitute. In SQ's place, 13 squared equals SR was given 12 squared plus QR squared. 13 squared means 13 times 13, which is 169, equals, and 12 squared is 12 times 12, which is 144, plus QR squared. The 144 walks across, we subtract with 169, we end with 25 is equal to QR squared. And then we will take the square root both sides, and we end with QR is equal to 5. So this means it's this tiny little side over there. Then we will move over to the big triangle in triangle SRP. And now we can say the theorem of Pythagoras, hypotenuse squared will be SP squared equals SR squared plus RP squared, that whole length of the building. We will substitute SP, oh remember it's Pythagoras. SP's length is 20 squared equals SR's length is 12 squared plus RP squared. 20 squared means 20 times 20, which is 400, equals 12 squared, 12 times 12, 144, plus RP squared. Let the 144 walk across. 400 minus 144 is 256, is equal to RP squared. We will take the square root both sides, and we end with RP is equal to 16. So that means this whole length there is 16. So we are interested in the length of PQ. PQ will be the whole of PR minus QR, 16 minus 5, and PQ's length is 11 meters. In the next lesson, I will discuss typical examination questions on the Theorem of Pythagoras. Click on the video in the left-hand corner to take you straight to the next video.